Okay, so today we're going to talk about what correlation is and then the difference between correlation and causality. Um, right, there's a famous saying in statistics that correlation is not causation, and that means just because two things are associated with one another doesn't mean one is causing the other. There's a famous statistics that in the summer, um, ice cream sales, or sorry, I just ruined it. God damn. So that ice cream sales and shark attacks are linked. They're associated, right? Meaning that when one goes up, when ice cream sales go up, so do shark attacks. They increase. And when ice cream sales go down, shark attacks decrease. Does that mean ice cream causes shark attacks? And the answer is no. Those are both associated with the summer, right? Ice cream sales tend to go up in the summer. And shark attacks tend to increase in the summer because that's when more people are in the water, so naturally more shark attacks are going to occur. In the winter, less people are going in the water, so less shark attacks are occurring. So no, it doesn't mean one causes the other just because two things are associated. And I'll show you a bunch of other what we call spurious correlations, like fake correlations, some of which are kind of interesting. All right, here we go. All right, so a correlation exists between two variables when higher values of one consistently go with higher values of another, or when higher values of one consistently go with lower values of another. And I don't really like the definition our text gives. It means a linear association. And a scatter plot is a graph in which each point represents the values of two variables. You guys have seen scatter plots in the past, I'm sure. So here's a couple of examples of different correlations. Height and weight for people is correlated. That is, taller people tend to weigh more because there's just more mass to them if they're taller. Shorter people tend to weigh less. Demand for apples and price of apples, so it's simple economic principles, right? Price and demand as demand increases, or sorry, as demand tends to decrease, demand tends to decrease as price increases. And practice time and skill among piano players. So those who practice more tend to be more skilled. All right, so let's talk about what like the way we can describe correlation. And so we're gonna describe it two ways: direction and strength. No correlation means there's no apparent relationship between the two variables. In a scatter plot, this just looks like random scatter. A positive correlation means both variables tend to increase or decrease together. So that in a scatter plot, it looks like a positive slope like this, up towards the right. A negative correlation means one variable increases while the other decreases, and that's going to look like a negative sloping line down towards the right. All right, so that's how you're going to describe correlation in terms of direction. And then strength, the more closely two variables follow a general trend, the stronger the correlation. In a perfect correlation, all data lie on a straight line. So perfect correlation just looks like a connect the dot. Okay? But the closer they are to following a straight line, the stronger the correlation. All right. So here's an example with positive correlation. I would say that this one is generally moderate to weak. If I had to draw a line of best fit, it would be like that. And it's definitely, you can tell there's a positive trend, but they're not really closely grouped around that. Here's life expectancy versus infant mortality rate. So in countries who have a high infant mortality rate, like Bangladesh, they also tend to have lower life expectancy rates. So those two things are correlated, but there's not a causal relationship between the two, right? In fact, it would be impossible for it to be a causal relationship. Infant mortality doesn't cause, well, that was going to sound ridiculous. Infant mortality doesn't cause low life expectancy, I guess, except for that infant. But it doesn't cause other people's low life expectancy. So what do you think is the underlying cause there? So there probably is a common underlying cause for countries that have low infant mortality, they tend to have high life expectancy, and for countries that have high infant mortality, they tend to have low life expectancy. Yeah, probably access to healthcare, right? So real quick, this isn't something you need to know. There's actually a value that goes with correlation. It's called Pearson's coefficient. And so it's just it's a computation that can be made that can tell us sort of the strength of the correlation. It's always a number between -1 and 1. And hold on before I show you the game. And the value of the correlation, so we generally use R to represent the value of the correlation. It's always between negative and +1. The closer it is to -1, the stronger, strong negative. The stronger the correlation is in the negative direction, and the closer it is to 1, the stronger it is in the positive direction. The closer it is to 0, the weaker the correlation, meaning the more spread out the scatter plot is. Does that make sense? So we'll do a guessing game, just to give you an idea about strength of correlation, and I think that'll help you decide whether you think a correlation is strong, moderate, or weak. We'll do a little guessing game. That's the word that I said, Aiden. Guess the correlation. So, new game. Let me enter a username. Yo, didn't I just do that? Okay, this is fun. Oh, dude, I'm not trying to play this against people. That's not the one I usually use. That's the one I want. All right, cool. So you guys can all see this. We'll do a sample of 25. There we go. And I want you to guess the correlation to 2 decimal places. So first of all, do this. Do you think it's going to be positive or negative? It's definitely a negative correlation. Does this feel strong, weak, or moderate? This is probably moderate to strong, right? The closer you are to -1, the stronger it is. The closer you are to 0, the weaker it is. So it'll take a couple tries, but you'll get the hang of it. So this is maybe negative, I'm going to say negative 0.71. Okay. Price is right, me? Oh, it doesn't matter. I mean, it'll still show us the answer. Ooh, this was really strong, negative 0.928. Okay, let's try another one. That's too similar. Oh, what about this one? Positive or negative? I think negative. Strong, moderate, weak? Pretty weak. Anybody want to take a guess? Knowing now that that one was a little stronger than you thought it was, or than I thought it was? Negative point. I'll say 2. Yeah, I think 2 is probably pretty good. Ooh, see? Still a little bit stronger. Negative 0.438. To be 0, like it's almost statistically impossible to have a correlation of 0 because they have to be perfectly spaced apart. You know what I mean? So there'll always be some correlation. New sample. All right, positive or negative? Somebody give me a guess. 0.6? I'm gonna say stronger than that. I'm gonna say 0.73. Oh, Trey got me. 0.619. Good guess. That one? Negative point something. Negative 0.9. Good. Negative 0.916. Because straight line is here, and it's pretty close to that. That one? Positive? 0.15? Good. 0.118. Pretty solid. Again? These points are going to be called, these are called influencers because this is really going to strengthen that correlation. If I took those 2 points out, it would be super weak, right? It would look like it'd be hard to tell if it's even positive or negative. But these 2 points definitely make it a positive correlation. Ooh, 0.388. .937. Ooh, 989. All right, so do you have a general idea about what the value of correlation is? So I'll show you this website of spurious correlations, and it gives you a bunch of things that are highly correlated, but it's supposed to show you that correlation isn't necessarily causation, right? So this is the correlation between spending on science, space, and technology in the US and suicides by hanging, strangulation, and suffocation. And they're correlated by 99.79%. And a lot of these, the common underlying cause is time. Like in this case, as time goes on, spending goes up in general, right? Just because the value of the dollar decreases. And also we're doing more space exploration now, and so it just costs more. And then as time goes on, also population increases, which means all kinds of suicides are going to increase over time. But that is a very high correlation. Number of people who drowned by falling into a pool and films Nicolas Cage appeared in.
I mean, people probably.
Hey. He gets hate. He's in some good stuff. Raising Arizona rules. Con Air is a classic. All right, per capita cheese consumption versus number of people who died by becoming tangled in their bed sheets, correlated by an R value of 0.947. Very, very strong. Now, this one, I'm a little bit suspicious of. There may be a causal link because too much cheese, a little easier to get tangled in your bed sheets. You get those cheese sweats. Look at the. You would think like the tangled in bed sheets deaths would be like relatively low, like single digits. It's like 800 people a year.
Like sleep on
I sleep on the floor. Just don't sleep at all.
Yeah. I think like 90% of deaths happen in a bed, so you just got to stay away from those.
You're not gonna get me.
It is.
under your covers.
It is true because people die in hospitals and old people die laying down.
Damn.
Divorce rate in Maine and per capita consumption of margarine. Again, maybe causal there. Your spouse starts eating too much margarine. Or your spouse is eating margarine at all, and you're like, yo, what is this, 1992? Eat butter, weirdo. All right. Here we go. Let's move on and finish up this section. So now you have an idea about whether correlation is strong, weak, or moderate. I think I've emphasized enough that correlation does not necessarily imply causation. What would you call these correlations? Strong, moderate, the first one, the pink one. How would you describe this correlation? Yeah. Yeah, so you could say relatively strong or moderate to strong. I would agree with that, right? And this one also positive, but moderate to weak probably, right? And so this makes sense, right? So this is the same day forecast versus the actual temperature that day. And this is the 3-day forecast versus the actual temperature 3 days later. And so you're going to have a higher correlation with same day forecast and temperature that day just because you have more information available to you for the same day forecast than you have for 3 days from now, right? Great. Okay, so there are 3 possible explanations for correlation, and this is like the stuff that you're going to be questioned about in your open note quiz and in the homework. First one, correlation may be a coincidence. This is your Nick Cage movies versus people falling into a pool. That one's probably just straight up coincidence, right? Second explanation could be both variables might be directly influenced by some underlying cause. That's like the ice cream sales shark attacks example. Both of those just happen to go up when the weather's hot because people want ice cream when it's hot and people tend to swim more when it's hot. And then the third one is a causal relationship. One variable actually causes or influences the other variable, okay? So coincidence, common underlying cause, or we have a causal link. Oh, Colin, sorry, I didn't see your question. All of those were real statistics. All right, and this is the one we talked about. So if we consider the negative correlation between infant mortality and life expectancy, which of the 3 possible explanations for a correlation applies? Probably common underlying cause, which was access to medical care or quality of health care in the country, right? Poor quality of health care tends to probably cause a higher infant mortality rate and a lower life expectancy. Whereas Good access to healthcare tends to be lower infant mortality rate and higher life expectancy. All right, so then how do we actually establish a causal link? And so here are some guidelines for actually establishing cause and effect. One, you want to look for situations in which the effect is correlated with the suspected cause, even while other factors vary. Ideally, you would like to do an experiment, although that's not always ethical, right? Because if you can do an experiment, you can have a treatment group, and you can have a control group where you keep all other variables the same for both groups, other than the thing you're trying to establish cause and effect about. But again, sometimes that isn't ethical. So in like the 70s, when they started to suspect that smoking caused lung cancer, the first reason they started to suspect that was because lots of people were smoking and they were seeing a correlation between people who got lung cancer and their smoking status, right? Now, it wasn't ethical to do an experiment once they thought that there was a possibility that smoking caused lung cancer. You can't then take people, force a group of them to smoke 3 packs a day and keep the rest of them off if you think it's going to kill the people who smoke 3 packs a day. But that offered a case control study, right? Because people either chose to smoke or not, and people also smoked at different rates. Some people had only a couple of cigarettes a day, and then some people a pack a day, and then some people 3 packs a day. All right, check that the effect is similarly present or absent among groups that differ only in the presence or absence of that suspected cause. And so 3 is kind of what I was just talking about. You want to look for evidence that larger amounts of the suspected cause produce larger amounts of the effect. And they did see that with smoking, right? They saw the incidence of lung cancer increase with the smoking rate of people. So people who tended to smoke like 3 packs a day got lung cancer at much higher rates than people who only smoked a couple cigarettes a day or smoked socially or whatever. So they saw that, right, as the treatment increased, the effect increased along with it. And so that's good evidence of a causal link. All right, account for other potential causes. This is just look for common underlying causes, okay? And try and weed those out. Test the expected cause with an experiment if ethical. And then try and determine the physical mechanism by which the suspected cause produces the effect. And so the physical mechanism for smoking was like smoke in the lungs. Okay. So let's look at a case study, airbags and children. When I was growing up, it was a big thing in my family to get to sit in the front seat when we were kids, like little kids. So there was always a fight about it. So me and my 2 sisters, eventually my mom got sick of us fighting over it and assigned us days of the week that we got to sit in the front seat. That seems insane now because you can't sit in the front seat until you're like 24 and can rent your own car or something like that. Obviously that's hyperbole, but you can't like a certain weight and a certain age. Like my son is 9, he's not allowed to sit in the front seat.
I remember when the airbag was broke. Like I remember because I used to work and see the airbag and I remember when it started.
Right. So that's what they did first, right? They made it so you could turn the airbag off, and then they were just like, nope, that's not solving the problem. No kids in the front seat.
Because then the airbag won't kill you. Fly through the windshield.
So by the mid-1990s, passenger side airbags had been commonplace in cars. And statistical studies showed that airbags saved many lives in moderate to high-speed collisions, but a disturbing pattern also appeared. In at least some cases, young children, especially infants and toddlers in child car seats, were killed by airbags in low-speed collisions. So at first, many safety advocates found it difficult to believe that airbags could be the cause of the deaths, but observational evidence became stronger, meeting the first 4 guidelines for establishing causality, meaning the greater risk to infants in child car seats fits guideline 3 because it indicated that being closer to the airbags increased the risk of death because a child car seat sits on top of the seat, which puts the infant closer to the airbag, right? And so to seal the case, obviously they couldn't do an experiment and just put kids in cars and crash the cars. But it did offer a good observational case control study because they could observe all the accident evidence. And then they could also do experiments using dummies. And we have enough science to know how much force on the average infant's head could cause severe injury or death. Like Mythbusters. And they found out that children, because of their small size, often sit where they could be easily hurt by the explosive opening of the airbag. And it also showed that the airbag could impact the child car seat hard enough to cause death, thereby revealing the physical mechanism by which the deaths occurred. What is it? Did you look it up, Shayna? 65 pounds?
No. It seems super light.
But the age requirement, like, or the I did
The age requirement is like 13 or older.
So
But
crazy.
in my group, it's like 100 pounds. Like we mentioned, and my little was like 100 pounds in 4th grade. We were like, no.
65.
I thought it was like 90.
Almost there.
All right. So there are basically 3 levels of causality that you may have. So you have possible cause, and that's just, there's a correlation. So that there could be a cause and effect relationship, although we have the other explanations, right? It could be coincidence, could be common underlying cause. Then you have probable cause. This means you have good reason to suspect that the correlation involves cause, because some of your guidelines have been satisfied, right? And then you have cause beyond a reasonable doubt. You found a physical model that is so successful in explaining how one thing causes another that it seems unreasonable to doubt the causality. This is usually legally the standard for conviction. And it demands that the prosecution show how and why, essentially the physical model, the suspect committed the crime. And note that beyond reasonable doubt does not mean beyond all doubt. True. Right. All right. So that's it. Listen, let me go over what's due.